All right. Hello and welcome everyone to this week's edition of Webinar Wednesday presented by Hawk Ridge Systems. My name is Jacob Ames. I'm an applications engineer here at Hawk Ridge. And on the line we also have another engineer from Hawk Ridge, Mr. Ryan Navarro, who will be here to help answer questions that you may have throughout this webinar. And this week's topic is going to be SOLIDWORKS productivity tips and tricks, which I have dubbed the tips and tricks grab bag. We're going to be taking a look across the board at SOLIDWORKS with a very broad scope. We're going to be looking at some different ways that you can improve workflows and increase efficiency while you're designing in SOLIDWORKS. Let's move on to the agenda here. Again, we're covering everyday tips and tricks. This is going to cover a variety of topics, but we are going to keep it to SOLIDWORKS core. So no simulation, no extra products that you may be familiar with. But my hope here is that everybody, whether you're a power user or if you're new to SOLIDWORKS, is going to walk away learning a little something. So we're first going to take a look at time-saving shortcuts, and this does not just include hotkeys. Hotkeys are great, but there's a lot of other ways to improve the speed with which you work in SOLIDWORKS, so we'll be covering several of those. We've got some productivity settings that we'll be covering as well. These are settings that I typically change from the default settings of SOLIDWORKS. So between system options and document properties, we can make some adjustments to these in order to work faster and more effectively. Then we'll be taking a look at some power tools and utilities. These are what I consider to be underrated SOLIDWORKS utilities or tools that you may not be using that you should be that can really help you out. We'll take a look at dealing with errors. Everybody from time to time has issues dealing with errors. And we want to talk about the workflow that we typically use to take care of those as quickly and effectively as possible. And then we'll look at improving assembly performance. One of the absolute most common questions that we get in technical support is slow assemblies. And there are a variety of ways that we can improve assembly performance. So we'll go through some of those. And then the final category, advanced commands. These are some of my favorite commands that I learned a little bit late in life that I want to share with you. Many of them you may be familiar with, but if you're not, we want to make sure that you have those in your tool belt to make your modeling experience with SOLIDWORKS as happy and effective as possible. All right? So to begin, we're going to take a look at our time-saving shortcuts, and I do have some hints here on the screen. So things like not just hotkeys. Again, we're looking at hidden shortcuts and a variety of hotkeys, so on and so forth, that can really help us out. So the very first one here, this was introduced in 2012, and this lets you find any command anywhere. This is the absolute first tip that I wanted to go over. This is known as the search commands bar, and especially for newer users, this is a really big one. SOLIDWORKS can be difficult when it comes to navigating through menus and things like that in order to find commands. And by default, your command manager doesn't necessarily have all the commands that you want. And so in this example, I was looking for a delete face command. If I come up to the top right of my screen here, you'll see a search commands bar. But when you first start up SOLIDWORKS, you're probably going to see something that looks like this, allowing you to search for SOLIDWORKS help. This is great, but in order to search for commands, you need to use the drop-down arrow right here. Make sure you're in commands, and then simply begin typing the name of your command, and SOLIDWORKS will search for it for you. Here you can see delete face is the first result, and you have a couple of options here. You can go ahead and click the command, and it'll start it up, or you can use the eyeball over here on the right-hand side to show that command location. I'm going to click this and take my hands off of the mouse, and what you'll find, and again, I'm not touching my mouse at all right now, SOLIDWORKS is going to go through, dig through those menus, and find that delete face command for us so that we know where it lives for future reference. Another thing I want to point out is directly from the search bar, you can also click and drag the command onto the command manager. So it's a really quick, nice way to customize your command manager and make sure you have that command for future reference. Now, also notice when I search for commands, some of these are grayed out. That typically indicates that you're not in the correct mode to be able to use that command. So it doesn't mean the command doesn't exist or it's not available. You're just not in the correct mode to use it. All right, so that's the search commands toolbar, one of my very favorites. Moving on, this is one of my favorite keyboard shortcuts. You can collapse your entire design tree with this clever keyboard shortcut. Some of you probably already know this. This is Shift-C, and this actually automates a command called collapse items. So especially in assemblies or very large design trees in general, you may come into a situation where you have a lot of expanded items and you have a very, very long design tree that you have to deal with. And what a hassle it is to have to come back through and manually close up all of those items. And if you right-click the top of the design tree, in this case it's the assembly icon here, if you right-click that, there's a collapse items option in the shortcut menu, and that's going to collapse your entire design tree. Quicker way to do this, in my opinion, if you like keyboard shortcuts like I do, hold Shift, press C, and that'll collapse your design tree and clean up that mess for you. Our next one, again, one of my favorite shortcuts, configure to your heart's content with this powerful dialog. No Excel required. So many of you are probably already familiar with design tables. For those of you who don't prefer to use design tables, we have another way to do that, and that's using the Modify Configurations dialog. Very easy to use, comes in a table format. We've got a simple example here to show how we can use this to create configurations very quickly. Now, how do you typically create configurations? So the manual ways to come over to the configuration manager, you add a configuration, you give it a name, and then you start going through and customizing dimensions and suppressing features per configuration, which is fine if you only have a couple, but if you need multiple configurations and you need to create them very quickly, this is where the Modify Configurations dialog really comes in handy. To access this, you can simply right-click a feature either in the design tree or the geometry in the graphics area, and rather than just modifying it, you can right-click it and choose Configure Dimension or Configure Feature depending on the geometry that you have selected. So in this case, I've chosen to configure my 6-inch dimension there, and you can continue adding dimensions to this table. So I've got the height, we can get the width, the depth. You can grab additional features just by double clicking. You'll notice that comes in with a suppression state. And maybe we want to grab the size of this. We'll grab a fillet feature as well. And then you can just start configuring it. Very easy to do. You can click where it says creates a new configuration very quickly. There's 3 additional configurations. Here's my 8x8 version with a 2-inch depth. And maybe we want to suppress, say, the fillets. We can do a 10x10. And I think you get the idea here, so I won't spend a whole lot more time going through this. But once you're done, you can click Apply. It'll generate those configurations, and you can also save this table for future reference by typing in a name and simply clicking Save. If you don't do this, this table disappears, so I always like to point this out. You can save that table view, and when I confirm, there's my number 1 configuration. It's a little bit larger with those fillets suppressed. 2, and 3, which I didn't change. So it's going to look the same as my default. From the configuration manager, I can go to my table, double click that and open it back up and continue adding features, dimensions, and making adjustments as needed. So in my opinion, very underrated. If you're not using this and you don't like design tables, it's a really great way to create multiple configurations very quickly. All right. If you've accidentally cleared your selections, and I think that we've all done this, you go through all the trouble of making pre-selections and then you click in white space and you clear your cursor. You can bring them back with this context menu shortcut. This is known as previous selection, and unfortunately there's not a whole lot of different ways to find this. So that's what I'm going to show here. Just as an example, if I make several selections here, maybe I'm selecting a variety of faces and edges and I'm getting ready to run a command, and say I've done this 50 times and accidentally click in white space. What do? Well, fortunately, if you right-click in the graphics area, in the context menu, there's an icon right here called Previous Selection. I've yet to find this command anywhere else. I'm not sure if it can be added to the command manager. I haven't been able to find it. But for all of you listeners out there, if anybody knows of another way to access this, please let me know. You can send us a question and just let us know where to find this. But as soon as I click this button, all of my selections are back, and you don't have to panic. All right, so that's the previous selection tool that has saved me a lot of time through using it. And then last but not least, for our shortcuts, if you're tired of closing open files one by one, if you work with a lot of files at the same time like I do, you can close them all at once with this window command, and this is known as Close All. In fact, I use this one so much I went ahead and assigned it to a hotkey. But right now, if you take a quick look, I've got 4 documents open. And every time I go and click X, it's going to ask me if I want to save it. I have to do this 4 times. I can just go right up to the window dropdown. I can choose Close All, which you can see I've assigned to a hotkey there, and close them all down, and that's it. It may come up with a dialog asking you if you want to save, but it's only going to be one dialog, and you can take care of all of these at the same time. So those are our time-saving shortcuts. That's going to take us into productivity settings. Again, settings, whether they be system options or document properties, that I like to change with respect to what the default settings are for SolidWorks. So again, we have a couple hints on the screen here. We'll get right into the first one. You can enable this setting to add dimensions on the fly while creating sketches. Instead of having to go back every single time and grab your Smart Dimension tool, you can enable on-screen numeric input for your sketches in order to create those dimensions on the fly. So let's go take a look at this. I'm in a sketch right now. If I go to create a circle, for example, I get a number that is attached to my cursor. Everybody should be able to see that. But remember, this isn't a dimension. This is just the current value for this circle here. So if I wanted to dimension this and fully define it, I'd have to come back, grab my Smart Dimension tool, apply the dimension, insert the value, and then confirm it. And that's kind of a pain. All right, so what I like to do is I'll come up to my system options here, go to the sketch category, and you're looking for enable on-screen numeric input on entity creation. What this does is it gives you a little input box so you can add a value directly and apply a dimension automatically. Now, if you're using this, you probably also want to make sure that the sub option, create dimension only when value is entered, you want that to be enabled. Otherwise, you're going to be creating dimensions for everything, which isn't necessarily what you want. So with that enabled, when I go back and I create my circle, notice I get my input box. I can just type in a value, press enter, and it assigns the dimension for me automatically, and we're fully defined there. So that's one of my very favorites, and I definitely wanted to share that one with you. Moving on, you can enable this ice cold tool, there's a hint there for you, in order to prevent specified features from rebuilding. Some of you may have heard this. This is known as the freeze bar, and what it effectively does is it locks features and prevents them from being rebuilt. Now, when I say it locks features, you can always unlock them. It doesn't prevent somebody from coming in and undoing that process, but it's a nice little tool. And you'll notice it's taken me a little bit to load this file up, and that is actually intentional. What I have here is a wheel, and it's got a nice tread pattern on it, but that tread pattern takes a very long time to rebuild. In fact, if I go to my Evaluate tab here and check Performance Evaluation, our total rebuild time for this is nearly 45 seconds, and that's not something that we want to have to deal with. Now, assuming that the rest of the work that I'm going to be doing is with respect to something other than that tread pattern, I can come up to System Options, and in the General category, near the middle of the screen, you'll see Enable Freeze Bar. When I check this on and click OK, you'll then find a yellow bar at the top of your Feature Manager design tree. Unlike the rollback bar, this one starts at the top and allows you to drag it down. And again, this is going to lock features. So if I come right after my circular pattern here, it's going to lock all of those. And if I save this in this format with this locked as it is right now, it's going to rebuild a lot faster. If I need to do a full rebuild, it's going to skip all these features that are locked, and it's going to rebuild everything else. Now, if I go back to Performance Evaluation, my total rebuild time, it'll let you know that it is with a freeze, not even 4 seconds. So this can be a really, really nice tool to speed up rebuild, especially if you don't need to work with those features. All right. Use this category of system options to add custom template folders, especially for you newer users out there. You need to be familiar with this. This is known as file locations. And in this example, I'm going to take the simplest example of adding templates, but the truth is you can add a lot of other information using file locations. If I start a new document right now, notice I have several tabs for templates. By default, you're probably only going to get 2 or 3 tabs here. But if you want to add new custom templates, you can use file locations. This is stored in system options as well. And you'll find file locations, that's a category about in the center of the list there. And by default, it's going to show you folders for document templates. But a quick look at this dropdown is going to show you we have a ton of different types of items that we can add so that the system can reference them properly. Things like weldment profiles, textures, thread profiles, you name it, it's probably going to be in here. So in this case, I want to add a folder for document templates. I'm going to go right to my file set here. The name of the folder that you add is going to be reflected in the new tab that gets created. So I'll choose my test templates and click OK. One other thing, when you see this dialog, you're going to reflexively want to click yes. You don't actually have to do this. This just adds a search path so that you can search for those documents later. And if you click no, it's still going to work. So you can go ahead and click no there. Now when I go to create a new document, you'll notice my tab for test templates carrying over that folder name, and there they are. All right, so this is the easiest way to add new templates and allow you to store all those document settings so that you've got the proper standards and everything else that you need. All right, you can use this section of document properties to control the fidelity of model edges. This is document properties, so remember, this applies to a specific document, which means that it can be saved in a template, and this is image quality. So I've got another example here. We saw this in the very beginning, and right now you can see the fidelity of these edges is pretty nice, but let's say you're working on a slower PC, or you're getting some graphical issues. When you go to rotate this, it's kind of choppy, right? What you can do is you can come up to, rather than system options, you can go to document properties. We have an image quality category, and we've got two sliders here, one for draft quality, one for high quality, for hidden lines removed and hidden lines visible. If I reduce this, what you'll find when I click OK is that we're going to get some wacky looking edges there. Now these don't look very precise. Obviously you don't really want to work in this extreme of a case, but if you have a very slow PC, if you need faster graphical performance, you can reduce that slider. Maybe not quite this much, but that will improve your graphical performance quite a bit. And again, that can be saved in a template. So if you want to reduce that, you can. And again, that's image quality. And then finally, for productivity settings, this 2017 option allows for the import of non-SOLIDWORKS files without translation. That without translation, that's the big deal here. This was introduced a couple years ago. It's called 3D Interconnect, and if you want to take advantage of it, you do have to make sure that it's enabled. So this is just going to take a second. We've got a big assembly that we're going to load up here. And we're going to show how we can take, in this case, I used a step file, but you can also use CATIA, you can use Creo, we can use lots of third-party documents, and we can bring them in without the hassle of translation, which oftentimes, unfortunately, results in errors. So I've got an assembly here, and I want to bring in a hydraulic cylinder to add underneath this truck bed here. And if I go to Insert Components, and I browse out, when you're doing this, by the way, make sure that you're not set to just SOLIDWORKS files down here in the bottom right. We want to make sure to set this to all files. I'm looking for my hydraulic cylinder, and we're going to use the step file. And when I open this, it's just going to read it. And the coolest part about this is that if the model is updated in whatever program it was initially created, it can be updated here as well. There's a ton of documentation on 3D Interconnect. I'm not going to get into it too much here, but notice no translation. If you have a look in the Feature Manager design tree, there's a green arrow superimposed over the icon there. And that's what allows for a link back to the original program. All right, so just something I wanted to cover there. In order to use 3D Interconnect, you do need to make sure that your options are set properly. In System Options, in the Import category near the bottom, you're going to find at the very top an option for Enable 3D Interconnect. You want to make sure that's turned on. And likewise, if you don't want to use 3D Interconnect, if you need that translation, you want to disable that. And this works for opening parts in assemblies or parts on their own as well. All right, moving on to the next category, we've got power tools and utilities. Some of my favorite tools and SOLIDWORKS utilities that I consider to be relatively underused. Again, some hints on the screen here. The first one that we're going to take a look at, this is an assembly command. It's, I guess, technically an evaluation command, but it's used for assemblies. And this color codes components to show mass, rebuild time, cost, you name it. There's a lot of different parameters that we can color code our assemblies by. Some of you will probably recognize this. This is assembly visualization. This is a really nice evaluation command that can do a lot of different things. So from the Evaluate tab, we'll go to Assembly Visualization. By default, it's going to color code this according to mass. So we can immediately tell that our cab here is going to be the heaviest, closely followed by the frame, then the bed, and we can see that things like the base or the plate back here and some of these other subcomponents don't have nearly that much mass. Now, you can change colors. You can move the sliders, right, to make some adjustments there. But what I want to focus on here is the ability to show other categories. You can show things like density, volume, surface area, etc. But if you click more on that right-hand arrow, you can select from a variety of other properties. Lots of sustainability options if any of you are doing sustainability analyses. But we also have things like open and rebuild time, in addition to Things like whether your components have external references, whether they're fully mated, or if they have a high graphics triangle count. We can check out all of these, but the reason I emphasize open and rebuild time is because these can help you identify components that are slowing down the opening or the rebuilding of your assemblies. So if we show rebuild time and I click OK, notice most of these things are actually not too bad, but those wheels, which we had to look at earlier, again, because I don't have those features frozen or suppressed, that's taken 45 seconds every time we want to rebuild it. So definitely a really valuable tool, help you spot issues and efficiency within your assemblies, and very important tool to have in your tool belt there. All right, let's go ahead and close these down. We're going to move on to another section here using that close all command again. And you can use this tool to move, rotate, or scale an entire sketch even if it's underdefined. Again, very underrated. This is the modify sketch command. How many times have you tried to make an adjustment to a sketch or translate it only to find that it's partially underdefined and you end up messing up the sketch? That's what modify sketch is really good for. To show this as an example, I'm going to make a quick copy of an existing sketch, put it onto our other plane here. We're going to go edit that sketch, and then from tools, we can go down to sketch tools, and here you'll find modify. Again, this might be a good example of where you could search for a command if you don't know where this lives. I'll click modify. We get a little dialog here. We can scale it. So if I want to change the scale, for example, 0.75, make it a little bit smaller. We can rotate it. We can translate it. And keep in mind, this is an underdefined sketch. If I just tried to click and drag this, we'd run into all sorts of problems. So modify sketch, super valuable. And just to finish this off, why don't we make a quick loft for fun? We'll do something like that. All right, so very easy to use, very valuable. Next up, this 2011 tool removes details from assemblies and parts, and this does include multi-bodies as well. This is known as the D-Feature tool. Very useful for simplifying models to be used in assemblies, so you do have faster rebuild times and better performance, but it's also good for protecting things like intellectual property. So if I wanted to send this to someone, maybe to fit another component to it, but I didn't want them to see the bolt pattern for whatever reason or something like that, the D-Feature tool can help here. So from Tools, near the top, you'll find D-Feature. This is going to end up splitting your screen, but for right now, it's just asking me what features I want to keep. So it's a multi-page dialog. You got to make sure to click the next button. Choose features that are critical. You can select all holes, etc. When you're ready, go ahead and click Next. This is where you'll see my screen split in half. It's going to show me the original on the left and the simplified version on the right. And you'll see in this case, it's gotten rid of all of those holes, all those extra details, because we probably don't need to see this in an assembly. All right, so we have a couple options here. You can identify additional items to be removed, or in this case, you can skip that. In some cases, it may ask if you're doing this at the assembly level, if you need to retain motion, you can identify information that needs to be kept for that. And ultimately, when you're done, you have a couple different options. You can store the settings for future use. If you want to just use this later on, you can save this model as a separate file. This is typically what we do. And when you save this as a separate file, you can also choose to link that to the original. That way it actually maintains a link between those two documents. I'm not going to do that here, but you can see what our end result would look like. And of course, this would perform quite a bit better in the context of an assembly. So that is the D-Feature command. Next up, you can quickly locate small faces and short or sharp edges with this SOLIDWORKS utility. This one's kind of hidden. I don't see this being used a lot, and I really feel like it should be. This is known as geometry analysis. And it does exactly what I just mentioned there. It's going to allow you to quickly identify faces and edges that are small, and this is typically an issue for manufacturing. Now, if I zoom into this hood that we have here, there are quite a few that you can spot, but there are going to be some that are hidden as well. So in order to make this easier, from the Evaluate tab, choose Geometry Analysis. Here you would set your parameters to identify what constitutes a small face or a small edge. Once you have those set, simply click Calculate. It's going to go through all your geometry, and it's going to find all those edges, faces, and vertices that could end up being an issue of some sort. So for short edges, it looks like I have a couple. If I rotate this around, yeah, that's a short edge. That's going to be kind of a problem there. All right, if anything, it's going to make modeling a little bit more difficult. We can go look for some sliver faces. There's another example. If I zoom in here, and of course those callouts are going to draw you right to them, so you don't have to go searching. I find this ends up happening most commonly when you combine separate multi-bodies into a single body, but it can really happen anywhere. And we've got a couple other pieces here too that we may be concerned with. So that's geometry analysis. Again, kind of underused, and I think it goes a long way to helping you identify areas in your models that may be somewhat of an issue. Moving forward, you can use this tool to create a continuous spline from lines and arcs. Smooth out those transitions. A lot of times I see people struggling with transitions, and that's where the fit spline command can really come in handy. So let's take a look at this. We're back to our wheel. This is my simplified version, so it loads a little bit more quickly. And notice all the edges that we have in the wheel. Now these are tangent edges, so they're technically continuous, yes, but they're not curvature continuous. And you can see this if you have a look at the curvature evaluation tool. You can see they're very distinct colors. There's no real transition between them. And in some cases, especially with consumer products, this can be an issue. So one way we like to take care of this is through the use of a fit spline. If I go find sketch 6 here, which controls all of that internal geometry, and I edit this, I just went normal to it there real quick. We can take all of this analytical geometry, that being our lines, our arcs, and we can create a fit spline from this. From the tools drop down, you want to look in spline tools specifically, and you'll see I don't have any splines in this sketch yet, so I don't have any other sketch spline tools to work with, but I do have a fit spline. Now this is kind of an interesting command. It doesn't have any window for you to input selections, so you just have to trust that it's keeping track of those. And I'm just going to start making my selections. Now you'll see kind of a weird pink line there on the screen. It's by default going to try to create a closed spline more than likely. In our case, we don't need that to be closed. We can keep it open. And we're just going to choose a few additional pieces here. You can choose whether it's constrained to the original geometry. Do you want to delete the original geometry? I prefer to keep the original geometry in case I ever need to change it. But if you wanted to delete it, you could. You can adjust your tolerance. And once you find a fit that you like, go ahead and click OK, and it's going to replace all those lines and arcs with one nice continuous spline. And what this ultimately results in is nice, smooth, blended curvature. And if we investigate that again through the use of our curvature analysis, you can now see gradients in the colors. All right, so a nice smooth transition that we don't get if we just have tangency between lines and arcs. So that is your fit spline command. Definitely a good one to be aware of. All right, moving on, we are going to address dealing with errors, something that everybody has had to deal with at one time or another. This is going to be a fairly basic overview of some tips and tricks, especially valuable to you newer users out there. We're going to start off by learning where to resolve errors in a part. You want to start with this feature in the design tree. All right, and this is just the very first one. Whichever one comes first in the design tree, that's where you want to start. And right now, you can see when I open up this part, there's nothing on the screen. There's no geometry whatsoever because we have so many errors. Now think about this. If I try to come to the bottom of the tree, which is where a lot of people like to try to start fixing errors, what feature do I have here? I have a fillet, right? That fillet has to be applied to some sort of existing geometry. So if I try to fix the fillet first, there's no way that that can happen. You need to start at the very top of the tree, right below the origin. Whatever feature has an error first, that's where you want to start. All right, and then moving on from here, this dialog becomes very important. This provides warning and error information for either a specific feature, or it can give you information for an entire file. This is the what's wrong dialog. The reason I bring this up, everybody's probably seen it, but it's very easy to just dismiss. If I right click the top level part here, from the shortcut menu, I have what's wrong. If you do this at the top level, you're going to get information for every error and warning in the entire part. And again, this is a lot of information. We can take this a step at a time, but it's important to understand what's going on here. It's easy to just click close and try to fix it yourself, but I can immediately see with the very first feature that this sketch can't be used. So I know just by looking at this what's wrong dialog, there might not be anything wrong with that main feature. It looks like it's actually going to be an issue with the sketch. You can also get this when you rebuild. Sometimes you'll see that come up. And if you want to see what's wrong for individual features, you can just hover over them in the design tree, or you can right click and choose what's wrong. And it's going to give you a good description and help you understand where to start. So that's the what's wrong dialog. And then building off of that, this tool allows you to check for what I call micro lines, extremely small lines, and tiny gaps within a sketch. This is one of the most common errors that we have to deal with, is very small accidental lines, little gaps that create discontinuity and prevent you from creating your feature or result in errors. This is the repair sketch tool. So coming back to our same issue here, if I want to get started fixing this, we already know from our what's wrong dialog that there's an issue with the sketch of the main feature. So if we go to edit this, I don't really see anything wrong with this. And that's the problem. These are very difficult to identify just by looking. So that's where the repair sketch tool really comes in handy. From tools, if we go back to sketch tools, we have a repair sketch command. And as soon as I do this, we're going to get a little dialog that's going to provide us with a magnifying glass and allow us to search for those errors. So you can set this to show gaps smaller than a certain threshold. And then I can zoom in with just this little magnifying glass, and you can see this tiny little issue is enough for our entire feature to fail. So we can go ahead and quickly fix that, drag those back together, and then when we refresh this, it's going to identify a couple other errors. Here's another one up in the corner, very, very small line. We want to take care of that one as well. And then the last error is actually showing us that we have a small entity that we probably didn't intend to use. And a trick I like to use for this is fit to screen. If I use fit to screen, which you'll see right here in the heads up toolbar, zoom to fit, also the F key for those of you who like keyboard shortcuts, there's a tiny little entity up here at the top of my screen, and that is going to cause a problem too. Another thing that I see folks running into, this is obviously a point, I'm going to click it, I'm going to delete it, and then I'm going to find an error that says sketch endpoints and center points can't be deleted. So what's actually going on here? Let's take a look. I'm going to zoom into this. Hopefully everybody can see this okay. And when I get in close enough, what do we have here but the world's smallest line? If you're zoomed out, you're going to end up clicking an endpoint which can't be deleted. But when you zoom in close enough, or if you do a box select, for example, over that, you can delete it no problem. All right, and that's going to take care of that issue for us. If we want, we can throw on an equal relation here to fully define that. And we do have other errors, which I would typically recommend stopping and repairing. You'll get another what's wrong dialog, but you can see that that first feature now has no issues. All right, the warning symbol is gone, and that repair sketch tool is a really great way to identify those issues at the sketch level, which are often the cause of your features failing. Playing off of this again, this is another type of reference that represents what I would consider one of the most common error types. This is dangling references. Okay, what is a dangling reference? This means that the reference exists, but SOLIDWORKS doesn't actually know what it applies to. And if I go hover over my cut extrude, that doesn't really tell us a lot. But if I hover over the sketch, which also has an error, you'll see this sketch contains dimensions or relations to model geometry which no longer exist. When you see this, this essentially means that there is a dangling relation. Okay, so let's go investigate that. A quick look into the sketch. You're going to see by default, it's difficult to see with the preview that we have here, but it's kind of a brownish yellow color of the sketch segment at the top, which I've highlighted in orange now. This is a dangling relation. It exists, but it doesn't know what it belongs to. So one quick way to identify this is through colors. You can also use display delete relations, and you can use the drop down to show dangling relations. You can also replace entities here. So I can take my dangling line 8, and if I click it, I can choose an edge that I want this to apply to. This is a collinear relation, and I want it to apply to the edge that we see at the top. So once I click that, I can choose replace, and it'll go ahead and fix that for me. Instead, what I typically like to do is click the sketch segment that is having the dangling issue, and then you'll notice a red handle attached to it. If you click and drag this, it's going to allow you to reattach this relation. So you'll click and drag that red handle, drop it onto the edge that you want it to be assigned to, and it'll snap into place and take care of that relation for you. Now you can see that sketch entity is black. All right, so that'll take care of that. Exit the sketch, and there's your feature. Okay, so that's dangling relations. You always want to take care of those, and that's a good way to do that. All right, and this expert tool can automatically fix certain fillet and draft errors. And this is just a disclaimer, this is about a 50-50 shot, okay? This is known as the feature expert. It does not always work, so don't put 100% faith into it, but it can be a nice tool, especially when it does work, of course. At the very end of this model, we have a few fillet features that are struggling. And so we want to try to take care of those. If I roll to the end here, it's going to give us that error. We can stop and repair them. And in the what's wrong dialog, what you'll find is yellow, first of all. And that's an indicator that you can use the feature expert, and then a new feature expert button. This is pretty much a click and pray type of situation. You're going to click the feature expert. It's going to do its thing. And what you'll find is that it's going to break up fillets and rearrange them in the order. And it's actually going to create additional fillet features here, but it's going to do its best to preserve the original intended geometry. So you can see we got some good results here, but it does change up our tree a little bit. We now have 6 fillets instead of 3. They're reorganized, so they're in a different order. But when this does work, it's a very helpful tool, and I definitely wanted to include that here. Now, I just saw a question come in about dynamic reference visualization arrows. This is a great question. I'm glad that it was asked. For those of you who haven't heard of this, what you've been noticing is as I hover over features in the design tree, I get blue arrows and purple arrows. Those blue arrows are the parents of whatever feature I'm hovering over. So what that means is that this Cut Extrude 2 feature can't exist without the main feature and Cut Extrude 1. Likewise, the purple arrows indicate children, which is the opposite relationship. If you want to turn these on, there's a couple ways to do it, but my favorite is just to simply right-click the top level icon, which you see right here. And from the context menu specifically, you'll find dynamic reference visualization for parent and child at the same time. All right, so you want to control those individually. You can have one on, you can have the other on, or you can have both. I love to keep these on. It's a really great way to understand the relationships between all of those features. So it's really good for dealing with errors and things like that. So great question, very appropriate for this section. And with that, we will move on to improving assembly performance. All right, again, one of the most often asked of our tech support, how do I make my assemblies faster? All right, so we've got some options there. For faster performance, avoid using components that are hosted on one of these. I don't have anything to show for this, but the idea is you don't want to be using any components that are hosted on a network server when you have to ping another server. That's naturally going to slow things down. So if you can use files that are stored locally, that's going to be the best for you. All right. Next up, this mode for subassemblies lets you show their motion, which is great, but you need to use that with discretion. This is known as making a subassembly flexible. So a flexible subassembly allows the internal motion of a subassembly to be shown. And this is really good, especially if you need to do motion analysis. Maybe you need to do simulation that includes motion with a top-level assembly, but it does slow down the system. So we're opening up that dump truck again. Should take just a second here. And what you'll find is that by default, my cab sub here, this is a whole subassembly with a few components, I can't move any of these. So if I click them and drag them, they're fixed. But the hood and the door, we want to be able to show the motion there. So in order to do that, I can right-click my cab subassembly. And then from the context menu, you should see Make Subassembly Flexible. If you don't see that, you can add it, or you can go to Component Properties. There's an option in there. But as soon as I make the subassembly flexible, I can now take these components, I can drag them up. There's the hood, there's the door, right? And I was always able to move the bed, but that's just because this is one single component. So keep that in mind as well, okay? This is great, but you want to use them with discretion because they do have a tendency to tax the system, all right? Let's close all of these out. And we'll move on to our next one here. This mode for assemblies invokes a special set of system options for faster performance. We have special modes that allow us to get more out of our assemblies. The one that I want to introduce first is large assembly mode. Now, typically what I do, this can be activated after you have an assembly open, but it doesn't do quite as much because the assembly is already open. I'm starting out with just a blank document here, and when you go to open that dump truck file, in my case, before I click open, I can change my mode from resolved, which is your default, to large assembly mode, and I can click open. And what you'll find here is that this is going to load up pretty quickly, certainly faster than it did in the resolved case. So in this case, we're looking at maybe 10 seconds or so. It's taking just a second here. There we go. You'll find some things look a little bit different. First of all, it doesn't show any model edges, so it's going to get rid of those by default. That speeds up the graphics a bit. And if we have a look, all of our components have been loaded lightweight. All right, so they don't show the individual features. You can resolve these independently if you would like to work on some of them, but it just makes things a lot faster. But what you'll notice is we still have motion, we still have mates, we still have quite a bit of functionality, and we can load any of these in at any time. And you're going to have a really good experience with this working in large assembly mode. One other thing I want to point out is that in the system options, if you go to assemblies, you can automatically trigger large assembly mode in order to improve performance based on how many components the design has. By default, it's going to be 500. So if you have a slower computer, for example, you may want to set this to 100 so that once you hit that 100 component threshold, it's automatically triggering large assembly mode. All right. If that's not enough, and sometimes, especially with extremely large designs, it may not be, or maybe you don't really want to do much. Maybe you just want to take a look at your very large assembly, or maybe you want to take measurements, things like that. We then have large design review. This goes the extra mile and makes this process even faster, but naturally there is a trade-off. So when you do this, you really can't do a whole lot. There's our dump truck again. This time we're going to change our mode to large design review. Like large assembly mode, you have an option to automatically trigger this. The default is 5,000 components to give you an idea of how large these designs typically are. When you go to open this, you'll get a splash screen telling you what you can do, and that's pretty much it. So when I click OK, it's going to take 1 second, maybe, and there's our large design review. Again, you see some graphical differences when I go to rotate this, but the thing here that you'll notice, there's no geometry, no information at all. We can just see essentially the structure of our assembly. All right, you can still do things like take measurements. They are approximate, so you may get a warning there. You can take snapshots, things like that. And then the one other thing I always like to mention, if you don't have the constituent components of this assembly, you can actually still open it with just the top level assembly file, only in large design review mode. So sometimes that can save you as well. Okay, and last but certainly not least, you can use this option while opening an assembly to create a new super simple configuration. This is known as the advanced configuration mode. So this one, again, not super widely known. When I go to open, we're going to do the same file again. If I change my configurations, I have a couple configurations that I have here, but if you click advanced, you get some interesting options here. So you choose advanced and click open. You get configure document as a dialog, and then you can choose to either create or open the currently selected configuration. Kind of pointless if you're using advanced open, but you can also create a new configuration showing all the reference models, or just the assembly structure only, which will just load everything suppressed. You can give that a configuration name, or you can use specified configurations for part references when it's available. This one's the most interesting to me. So if I check this on, and all the components that I use in my top level have a configuration called simplified, it'll automatically build a new configuration at the top level that represents all the simplified configurations of every component. So this can save you a ton of time. And for example, when I took the tread off of my wheel, that might be my simplified configuration. So this is very powerful. Just to give you an idea of what the new configuration showing the assembly structure is, we can show that real quick. It'll create a new configuration. As I said, everything's suppressed. It's stored as a new configuration, which I called structure, but this can give you a good idea of what components are built into this dump truck assembly. All right. So a few tips there. Hopefully that will help you get your assemblies to speed up a little bit. And with that, we're going to move into our last category here, trying to move on pretty quickly, advanced commands. Some of my favorites, if you don't know about them, especially you newer users out there, these are advanced commands that you should be familiar with, that are going to really help you move forward and build more intelligence into your designs, which is something we always want. Patterns. You can use this pattern option for linear patterns specifically to automatically calculate either spacing or a number of instances based off of a reference. This is known as the up to reference option. We're going to demonstrate this using a simple linear pattern. back to our exhaust cover here that we've seen a couple times. Now, when I was building this, what I wanted to do is I wanted to make sure that this pattern went all the way down to the bottom, that pattern of holes, but I wanted the flexibility to be able to change that at a later time without losing that number of instances. Or, on the other hand, I could change this to make sure that we retain the same number of instances, but they space out evenly. From the linear pattern command, once you choose your direction, in this case, our top plane, rather than spacing in instances, which it defaults to, this is great, but it doesn't allow you the flexibility of up to reference. We can choose up to reference. Let's get our features loaded up here. And rather than just controlling the spacing and number of instances, maybe you don't know them, maybe you want more flexibility, you essentially assign a point or a reference at which you want the pattern to stop. So you can see as soon as I click that reference, it goes all the way down to the bottom, and then it stops automatically. And then I can just control the spacing. And what you'll see, and this is especially obvious when we increase our spacing a little bit more, as I increase my spacing, it's going to space those out. And then as soon as it gets past that threshold, it removes that instance. All right, so it automatically calculates the spacing. But we could go the other direction too. Maybe I have a specified number of instances that I want to use. Now you may need to use an offset here. In this case, I need to offset just a little bit. There's 4 instances. As I increase this to 5, it changes the spacing. There's 6, right? And then the coolest part about this is, once I create this pattern, it builds that intelligence right into the model. So now if I increase the size of my cylinder, for example, it's going to retain that same number of instances and just automatically change the spacing for us. All right, and you can go the opposite direction if you want to retain the spacing and add additional instances. This is something that I see a lot, and it's really, really powerful. I had a question come in with respect to this. With that up to reference in the patterns, have you had issues where you have all of the correct info needed, but it bunches the holes into a small space? Even if it's an endpoint of a sketch, sometimes it doesn't go to the end. What I will say, Pat, thank you for the question, by the way. That is a good question. I would definitely make sure that the property, I know this is a very generic answer, but you want to make sure the property manager is filled out. If everything's being bunched up into a small space, that would indicate to me that there is an issue with the geometry that you're using to represent the threshold here, or it could be an issue with using a selected reference rather than a centroid. So one thing that I see sometimes, if it doesn't go all the way to the end, you may need to use a selected reference on your feature, which I can't really do with a circle, so this isn't a great example. But sometimes we have issues where the circle will bleed over a little bit, and that selected reference may be able to help combined with the offset there. So I'd have to see a specific example there, but try messing around with your up to reference, your green and purple boxes here, your selected reference, and hopefully that will help a bit. All right, moving on, our next command. This is a sketch command that creates an identical linked copy of an existing sketch. Super underrated. This is known as the derived sketch. This is not the same as a copied sketch. Okay, so let's take a look at an example. First, we'll copy the sketch. All right, so here's sketch 2. We're going to take that sketch 2 and paste it on a plane. Now, if I take the original sketch and I click it, I drag it, I resize it, I rotate it, the second sketch that I copied doesn't care. It doesn't change at all. There is no relationship built into this. On the other hand, if I create a derived sketch, it's always going to look exactly the same as the original sketch. The tricky part here is knowing how to actually create the derived sketch. And the way to do this is by selecting the sketch itself and the destination plane. So I have to use a control select to get both of those. Then you can go to Insert and then Derived Sketch. This is the only way to do this. And what you'll find now is that when I make an adjustment to the original, I can rotate it and resize it a bit, right? The child sketch or the derived sketch is going to respond accordingly. So this allows you to build good intelligence in here. And I really like this. We see a lot of people in aerospace using it too for things like airfoils and stuff like that. Super valuable in loft and boundary features as well. So that is a derived sketch. Next up, this command allows you to combine existing edges, sketches, or curves into one continuous curve. super useful. This is the composite curve, so it is a curve type of feature. Again, it can take 3D sketches, it can take curves, it can take edges, and it can combine them all into one entity. And this is important because, for example, if we started a sweep here, and let me just get a circular profile set up, I have only one option. I can do either the 3D sketch or I can do the curve. And in fact, I can only do one of the two curves that are blended together here. Even with the selection manager, it doesn't help when you have different types of entities. So what the combined curve will do, and this is a feature, by the way, it's not considered a sketch tool. You go under curves, composite curve, you're just choosing entities to join. So I can do a quick box select of all those, or in this case, it looks like I have to select them individually. There's all three of those curves, and it builds one curve out of it. Now when I go back and create my sweep, I have no problem. All right, I can choose the entire path and we get a result that looks something like this. All right, now just as a side note here, you'll notice that we have some transition issues. If you needed to take care of this, you can also convert curves back into 3D geometry, 3D sketch geometry, and then you could use a fit spline on that in order to smooth out that transition. So just a side note there. With this next command, you can add, subtract, or intersect bodies with this command. And I say George Boole would be proud, founder of Boolean algebra. This is the combine command. Very useful when you're working with tool bodies or multiple bodies, or when you run into a scenario like I had an issue here. If I take a quick section view, what you'll find is that I created a shell that I only wanted to affect the top of the little roof that I have here, but it actually affected the whole body. So how did I get around that? Well, first, I created a split feature, and I placed that before the shell. And what that did is it split it into two separate bodies so that the shell feature only affected that upper body. But then I ran into another issue because now these are two separate bodies, and the way that I had intended this to be designed was as a single one. You can see two solid bodies up here. So how do I get these to combine into one solid body? Well, there's the combine tool. So I like to search for this one, just another example of where you can leverage these search commands. We can combine those. This is going to be an add operation type, so we can just choose these two bodies and it'll combine them together, provided they're either intersecting or at least touching. Subtract is really good for tool bodies, subtract one body from another, and then common will take only the intersecting resulting volume of two bodies. So with a quick add, I'm able to combine those back together, and you can see now we only have one solid body and our shell feature is still intact. So that's combine, very, very useful, especially for advanced part modeling. And then the very last command that I would like to share with you today, the ability to turn multi-body parts into discrete part files with this powerful command. There's two ways to do this. I'm going to show save bodies. That's my favorite. You can also use insert in a new part. I encourage you to research the differences between the two, but we're going to show the save bodies command. Now, I've opened up the frame of the dump truck here, and I built this as a multiple body part, known as a multi-body. So if, for example, I wanted to take just these fenders and I wanted to save those out so that I could continue working on them without working in this entire frame model, how would I do that? This is very commonly asked, and fortunately, it's very simple to do. Whether you're using a cut list, like I am in my case, or if you have a solid bodies folder, a simple right click of that folder will allow you to choose Save Bodies. And this command's very simple. You just have to click the bodies that you want to save. Here's the first fender, there's the second fender, and then at the bottom here, you'll see there's my new file name. So it's automatically assigning a file name. If you double click this, you can go ahead and save these out. So we'll do fender 1. Let's try a different number here. Fender 3. And we'll do fender 4. And you can also propagate visual properties too, if you want it to have that same color. And you can also automate an assembly from this as well. We're going to keep it simple. I just want to save those bodies out. Once we've given those a directory and gave them a name, go ahead and click OK. And in just a second, we will be able to see that we have individual part files that are discrete. And here we can propagate the visual properties. Let's go ahead and let these load up. It may take just a second here. All right, and then if we go check our parts, There's our fender 4. A quick rebuild will take care of that background issue. And then we have fender 3. All right, so we now have 2 unique part files that live on the system. Notice in the Feature Manager design tree, there is a right-facing arrow that indicates an external reference or an in-context relation. So changes that we make to that frame, the initial part that we had open, will propagate here if we modify the fender there, but we can continue adding additional features and making modifications at this level as well, and this can be added to assemblies independently of the rest of the frame. All right, so very popular, very powerful command, and that is the save bodies command. And with that, that's going to bring us to the end of this webinar. I want to thank you all for coming. I hope you enjoyed. And for those of you who don't know already, we do have an excellent YouTube channel. Come find us, Hawk Ridge Systems, youtube.com. We have a great channel. If you enjoyed this presentation, we have literally hundreds of videos showing a variety of tips and tricks that you can check out. Really good learning resource. And of course, feel free to visit us at hawkridgesys.com. Get a hold of us. Our tech support line is always open for you guys, and thank you for coming. So with that, we're going to get into Q&A here. We've got about 15 minutes or so if you guys want to stick around and ask questions. I'll be combing through all of these questions and making sure that we get them answered. A common question that I've seen coming in is if you can get this recording. Yes, you will be able to get this. We'll be sharing it via email, so don't worry about that. And let's just go ahead and start at the top here and see what we've got. I do see it looks like it's a fairly common issue to have bugs with the up to reference option in patterns. My suggestion there would be, of course, play around with the property manager. I'm sure all of you have already been trying to do that. So what I would suggest is using the help file just to make sure that you're not missing anything. And then check out our video on the YouTube channel. We've got an up-to-reference video that you should be able to find just to make sure that there isn't anything missing. Unfortunately, without being able to see the files and exactly what's going on, it's hard for me to say where the errors are occurring. But yeah, just do a little bit of extra research and some practice. And remember, tech support can absolutely help you with that as well. They'll be able to see your screen, make adjustments to your models, and help you figure that out. All right. Somebody's asking if I can do a follow-up to this webinar. I'm glad you liked it. Thank you, Ross. Let us know. If I get the okay from marketing, I'm more than happy to do another one of these. I could have gone for probably 4 hours with this webinar, so I just wanted to take basically my top 30 and try to pass that information along to you. So I'm glad you enjoyed. Let Hawk Ridge know if you like this. Leave us some comments. Let marketing know. And we'll absolutely try to get another one out there. I'm glad to hear that you enjoyed it. We had a question on changing the stock reference of a saved body. Ken, that is a good question. That is, depending on the complexity of the scenario, that can be either relatively easy or it can be very difficult. If you want to change the stock reference of a saved body, what I would recommend doing is editing the saved bodies feature of the parent document and essentially severing the initial link and then trying to save it out again. So I'd need a little bit more information on what exactly you were trying to accomplish, in the sense that are we trying to completely replace the component? Are we just trying to get it to reference something else? There's a couple different ways to do that. Again, I think that might be something that tech support can help out with, depending on if there's any errors involved. But yeah, I would probably go back to the initial parent document and adjust the save bodies feature there. And that's the great part about saving bodies as opposed to inserting it into new parts. With save bodies, you have a feature to make adjustments to, whereas with insert into new part, you really don't. So give that a shot, and hopefully that will work for you. We have a question. The holes won't show on the assembly when using the hole wizard feature. Good question. Again, hard to say exactly what's going on there. I think if I'm interpreting this correctly, what may be happening is you're using the hole wizard in an assembly and thereby creating an assembly level feature. All right, so when you use a hole wizard command in an assembly, it's going to create an assembly level feature, meaning it only exists at in the assembly. It doesn't actually go down to the component level. So the way to deal with this is in the Hole Wizard command, near the feature scope part of the group box at the probably the very bottom, you should be, and in fact, you know what, I may be able to show this real quick. Let me go ahead and see if I can get my dump truck open, because I think this would be better to show. So it shouldn't take more than a couple seconds here. Let me get this loaded up. And let's say, for example, a couple more seconds here. All right. So let's say, for example, I wanted to put some holes in the tailgate, right? If I go straight into assembly and I go to my assembly features, you do have an option to create a Hole Wizard feature. All right. But what you'll notice is that under feature scope at the very bottom of the property manager, by default, this checkbox will be empty. So propagate feature to parts. That's what you want to make sure to check on if you want to create this Hole Wizard feature and actually have it go all the way down to the component. The other way to do this that gets a little bit more involved is to take the component and edit the component in context. You can click it and choose Edit Component in the Assembly tab, and now you can use a standard Hole Wizard feature just like normal, and it should apply those at the component level as well. All right, so hopefully that helps. Just keep those in mind, and that should get you on the right track. Good question, Connie. Thank you. Interesting question from Nicholas. We've got, in the linear pattern tool, is it possible to pattern in both directions? As an example, a center point and making a linear pattern in 4 directions. 4 directions at once. I don't know about that. Let me open up an example part here. We'll put a couple holes in this guy. Let's just do a real simple through cut. You can pattern in 2 directions. So I'll show you an example of kind of how I would go about that. Let's go ahead and just get a through all hole here. And if we go over to our linear pattern, you can pattern in 2 directions. So I'll go in the X direction, and then we'll go in the Z direction in this case. Let's grab our feature here, just a simple hole. So you can create a 2-directional array. Just do a simple example with spacing and instances. So we create something like this. And then for direction 2, same idea. So that's your most basic 2-directional pattern. If you wanted to go in the opposite direction, you can do something like this. So for direction 2, you can choose another reference that just has the same direction, the same orientation, or you could even choose the identical reference and then just reverse it. All right, so it'll do that. If you choose to do this, by the way, make sure that you're only patterning the seed. Otherwise, you're patterning the results of the first direction, which can cause some issues. So you can get a pattern like this. And then what I would say from here, if you wanted to go in 4 directions, I would start off with a pattern like this, confirm that. And then what you can do is you can use a second pattern. And then for direction 1 and direction 2, again, we're going in the same direction, just reversed. Make sure to pattern the seed only, and then I would choose instances to skip. So if you're, I'm assuming you're trying to get like a plus sign or something like that, you can skip some of those instances and try to make that work. But your mileage may vary with that. So just be aware, you may have to use a combination of multiple pattern features in order to get that to work. But good question. I hope that gets you on the right track there. Is it possible to rebuild everything from child to parent, both the model and the drawing, in one command? If I'm understanding your question correctly, a rebuild of the part that you're documenting should update the drawing automatically. So let's create a drawing from this real quick. I'm wondering, because I'm sure that you've tried it before. Let's go ahead and get our drawing view in here. So there's my drawing view. We'd do a projected view. And let's say I go back to my SolidWorks part and I get rid of my linear pattern. right? So now we just have one hole in the hood. When I rebuild this and I come back to the drawing, it should automatically update. So if you're not seeing something like this, if you're lacking that associativity, there may be an issue with references between the parts that you're using and the drawing. So that might be something, again, tech support might be able to help you out there, but just make sure that you're actually using and have the parts open that are represented in your drawing. Because if you don't have this associativity, then that means that there's something else going on. I hope that answers your question, but let me know if it doesn't, Edmund. Nathan, thank you for the suggestion. Going back to creating a hole in assembly, it's also worth noting that you may only be creating a hole through certain bodies, but not all of them. Once again, that can be controlled by feature scope. So, for example, if I wanted a hole wizard hole on the back here, you may by default be going, say, through the entire assembly, or on the other hand, you may only be going through one component when you need multiple components. And the way to deal with this is through the use of feature scope. So in the assembly tab here, when I go to create my hole wizard feature, at the bottom you have feature scope. This controls which components are going to be affected by the hole. You can choose all components. By default, it's going to be selected components with auto select on, which will choose all visible components. But if you disable auto select, you can choose which components are going to be affected by the feature that you're creating. So feature scope is very valuable. I highly recommend getting familiar with it because you can build a lot of intelligence and have a lot of flexibility when you leverage those options. Ken has, let's see, I have a multi-body part and I have saved the multi-bodies and then created an assembly out of them. He's then making a copy of that assembly and everything included in it as a backup. But the backup then maintains the reference to the original file instead of the backup. Ken, this is an excellent question, and unfortunately there's no very easy way for me to show you how to deal with that. This involves taking care of external references and actually stripping them out and recreating them for your backup there. That's something that we teach in our assemblies course. Unfortunately, that's a little bit too in-depth for me to go into right now. But basically what you can do is you can take all those in-context references, and if you remember when I showed sketches, let me get back into a sketch here real quick. Let's find a good one. When you edit a sketch, if you go to display delete relations, you can look for defined in context or external. These are the relations that you would need to take care of at the sketch level to help you essentially rebuild those relationships. But you may also need to do this with features too. It may not be specific to just sketches. Things like end conditions, up to references, etc. You may have to, unfortunately, there is a little bit of manual labor that's required to deal with those, but hopefully you get the idea. It sounds like it might just be a little bit of work. That may be something that we can assist with, but I can't guarantee. It really just depends on the nature of the work. Good question in from Edmund. What is the difference between a configuration and a derived configuration? In what situation should I use one versus the other? Fortunately, this is a pretty easy concept, but as far as when you should use one versus the other, it really depends. Basically what this does is it allows you to create a configuration that is a child of an existing configuration. So if I add a derived configuration, and I'll call this derived, we now have our default and we have a derived configuration. I'm sure you've seen this before. You've probably seen this in Weldments before. Basically what this means is that anytime I change the parent configuration, the default configuration, those changes are applied to derived. So for the default configuration, maybe I want to suppress, we'll just suppress our hole. We'll keep it really simple here. If I suppress that in the default configuration, it's going to be suppressed in the derived configuration. But this is a one-way street. So if I change this in the derived configuration, if I unsuppress that and go back to default, notice it's unsuppressed. So anything you do to the original is going to be reflected in the derived, but not vice versa. So that's what that is. I've got a couple more questions here, but I do need to start wrapping up. So we'll go through a couple more, and then if you have additional questions, feel free to reach out. We'll try to answer those, but we'll be getting out of here in just a few more minutes. In just Windows Explorer, when I right-click, I no longer have access to the Pack and Go, Rename, and other SOLIDWORKS functions. Great question, Ben. This feature is not gone now, but I've had, okay, it looks like it just got answered by Ryan as well. It is an installation issue. I've had the same thing. It's possible that you'll need to either reinstall SOLIDWORKS Explorer or do a repair in order to enable the option for those context menus, but the features do still exist, and they still function the same ways they have before. And then one last question to wrap up here. James asks how we enable the dynamic reference visualization arrows. Very easy to do from the Feature Manager design tree. If you go up to the very top level, in this case, it's the name of my part right here at the Feature Manager design tree. If you right click, you'll get a context menu. It's a very thin context menu. And here you can see on my cursor dynamic reference visualization for both parents and child features. And you'll need to enable both of those. All right, if you want to see both of them, you can enable them independently as well. That's the easiest way to do it. And again, very good tool for paying attention to all those references that can get a little bit complex when you have an advanced part. All right. All right, I believe that is all the time that we have for today. I want to thank you all so much. I hope you enjoyed. Again, check out our YouTube channel, like, subscribe. We've got awesome videos there to help you answer some more of these questions should you have them. Thanks again, and we will see you next time.